Okay, so today we are talking about writing equations with two variables. We've been writing equations with just one variable, and we've been solving for that variable and checking our solution. So today we're going to start learning how to write equations with two variables. An equation that has two variables represents two quantities. So before we had one variable which represented one value. Now we're going to have two variables that have two values that change in relationship with one another. So what that means is if one changes, then the other value will change. But if the one value doesn't change, then the other value doesn't change. So they're all in relationship with each other. Make sure you pause at any time to get all of these notes. So a solution, we start off with what's called a solution, which is a fancy word for answer, of an equation in two variables is an ordered pair. So we've used ordered pair to graph, but now we're going to be using ordered pair to help us find a solution of an equation with two variables. And it has to make it true. So when we're checking our answer with the one variable, and we had to go through all that work to find that check to make sure that one side equaled the other side. For example, 5 equaled 5, right? We made it true. That makes it true and it makes it correct. So now we're going to use ordered pairs, and that's going to help us. So we're going to use what we have called independent and dependent variables. So we have two variables, right? We said we're having two variables. So we have what's called independent variable. And over here, I'm going to write dependent. And our independent variable, well, this independent variable can change freely. So this one can change freely. And when this independent variable changes freely, it causes change in the dependent variable, because the dependent variable depends on the independent variable. So I'll say that again. You have your independent variable, and when this independent variable changes, so does the dependent variable. They go hand in hand. If one changes, the other changes. So for example, think if you have a mom and a kid. And your mom says, okay, honey, time to go to the store. Well, then you're gonna go to the store. But then your mom says, no, wait, now we're gonna go to the zoo. Well, now you're going to the zoo. You wouldn't go to the zoo without your mom saying, hey, let's go to the zoo. So the independent variable kind of is like the decision maker, and the dependent variable will do whatever the independent variable tells it to do. Please pause, make sure you get all these notes in your math journal. So we said we have the independent and dependent variable, and the solution is of the equation in two variables is an ordered pair. And if you remember, we had ordered pair, we had x and y. X always comes first, then we have our y. Well, when we're putting these into our solution for our independent and dependent variable, x is always the independent variable. X is always the independent variable. And the Y is always the dependent variable. So your X is your independent variable, and your Y is your dependent variable. And that doesn't change. X is always independent, D is dependent. So if your X changes, then your Y changes. Make sure you pause this to catch up if you need to. So let's see, how do we use the ordered pair in order to determine if the solution is correct or true? So copy these directions down. Determine whether the ordered pair is a solution of the equation. So let's look and see what we mean. Make sure you pause if you need to catch up. Y equals 4x. And then I have 0, 4. So if you remember, we have our coefficient, which is 4, and our x is our variable. The operation we have here is multiplication. So it's really 4 times x. So just like we did when we were checking our solutions, we plugged in values for our variables. Well, in our ordered pair, we always know that x comes first, then y. So I'm going to go ahead and I'm going to plug in my values for my variables. So my x, we say, is 0, and my y is going to be 4. So now I have 4 equals 4 times 0. Now I solve. I have to solve 4 times 0. Well, 4 times 0 is 0, so I have 4 equals 0. Well, is that true? Does 4 equal 0? No, it does not. So your answer to this question is no, because it says determine whether the ordered pair is the solution. And we said, is the solution, it had to make the equation true. This is not true. 4 does not equal 0. 4 equals 4, but 4 does not equal 0. So your answer to this question would be no. This ordered pair does not work for this equation. Let's try another one. Y equals 7x plus 2, and my ordered pair are 2, 0. So the first thing you do is plug in your values for your variable and see if they work. Remember, we have x and y. X and y. Our 2 is our x and our 0 is our y. You're just going to plug these values in. So for here, x, I have 2, so it's 7 times 2 plus 2. And now I'm going to plug in my 0 for my y is 0. I'm just changing the values for the variable. Now you can see here I have 7 times 2 plus 2. Brings me back because I have more than one operation. I have multiplication and adding. So I go back to my good old friend PEMDAS. No parentheses, no exponents, but I have multiplying and dividing first. So I'm going to do 7 times 2. 7 times 2 is 14, so 0 equals 14 plus 2. Done with multiplying and dividing. Now I can add. 0 equals 14 plus 2 is 16. Is that true? No, 0 and 16 are not the same. So my answer to this would be, again, no. This ordered pair here does not fit into that solution. Let's try another one. Let's try sorry guys, hang on one sec. Y equals 5x minus 10, and my ordered pair is 3, 5. Pause this and see if you can do this one on your own. Is this ordered pair a solution to the equation? All right, you should have paused it and you should have tried it, and you plug in the values for the variable. So I'm going to plug in 3 for x and 5 for y. So I have 5 times my x is 3 minus 10 and my y is 5. Again, I have more than one operation. I have multiplying and subtracting. Using PEMDAS, I'm going to multiply first. 5 times 3 is 15. 15 minus 10. I'm just carrying this straight down. Now I'm doing 15 minus 10 is 5. And 5 equals 5. Yes, it does. It checks. So my answer is yes. 3, 5 is a solution to this. Let's try one more and see if you could figure this out. Y equals 2x. And our ordered pair is 3, 6. Remember, 3 is my x and 6 is my y. Y equals 2x, 3, 6. Pause here and try to solve it. Okay, so you paused it and you tried to solve it, and you should have plugged 3 in for x. So we have 2 times 3 and 6 for y. 2 times 3 is 6. 6 equals 6. That checks out. So your answer is yes. This does work as an ordered pair. So we will be practicing more of this week, and watch the video again if you need to revisit some information, and pause again. Make sure you have all your notes in your math journal and you titled your title of contents.